So, good evening, ladies and gentlemen. Gianluca Messier speaking from Rome, Italy, on the behalf of the Virtual Telescope Project. And it's a pleasure for me to be here once again, sharing live in real time the wonders of the universe. Tonight, we are here to spy this wonderful supernova in Messier 101. I was checking the weather, sorry, because the wind has been an issue recently. You know, this live event was scheduled to be live yesterday, but because of the very strong wind, we could not open the live feed. Just checking a few things before I start. I started this earlier than scheduled because I suspect the wind is going to be stronger and stronger. So just trying a few things before I can start this regularly. And here we are back again. So I can start this officially now, so I'm happy that after all we are going to share this supernova live. As I say, we are just going to use the robotic telescopes part of the Virtual Telescope Project facility in Italy. Gianluca Masi speaking from Rome. And as I said a few days ago, on May 19, we were happy to learn that a new supernova was discovered relatively close to us. This is the supernova 2023 AXF, and this one is hosted by the wonderful spiral galaxy you can see right here, Messier 101. And I'm just going to share with you what the telescope is capturing while I am speaking. Just give me a handful of seconds if you don't mind. Okay, just going to open the telescope console and share it with you. Here we are. Okay, we should be set now. Here it is. So at least we have the telescope console. We can see when the telescope is pointing not far from the Big Dipper, because the host galaxy Messier 101 is just in that region of the sky where the Big Bear, Ursa Major, that is with the asterisk Big Dipper, is located. The telescope is already just pointed there. I am closely monitoring, as I said, the wind. Should the wind increase, I will need to close the telescope, so I just want to start sharing images of this galaxy with you. The telescope is already up and running. Let me see if I can share with you the telescope as well. Okay, here it is. Let me share the telescope. Here it is. You can really see in the moonlight the telescope pointing high, not far from the zenith, just overhead. So that is the telescope at work while I'm speaking, but we are going back to the telescope console, and I will ask our telescope to start taking images. And while this starts, I want to tell a few things about this huge, amazing event. As I told you, a supernova was reported to the astronomical community in this galaxy on May 19, and it was Koiki Itagaki, a great Japanese amateur astronomer who discovered really a lot of supernovae, and this one is of particular interest because it is just showing in a relatively close galaxy. Keep in mind, we are seeing the death of a star which is outside our own galaxy, our Milky Way. The host galaxy is Messier 101. This very beautiful galaxy was discovered in 1781 by Pierre Messier, a colleague of Charles Messier, a colleague of the famous Charles Messier, and this is why we call this Hem, because this one belongs to the legendary Messier catalog. The distance of this galaxy, hence the distance of the supernova, is about 21 million light years. So while we are spotting this explosion now, actually it took more than 20 million years to the explosion to reach our Earth. So actually this happened a long time ago. But as I said, this galaxy is relatively close in a cosmological sense, and being the supernova terrific in brightness, it is showing pretty bright. But what is the supernova? Here it is, my friends. Let me see if I can actually show you using the cursor just to tell you who is who. This one is the supernova. As you can see in this image captured by our robotic telescope from Manciano in the Italian Maremma in Tuscany, you can see in this very small area the brightest star is actually this one. All the other stars around are just part of the Milky Way, and the galaxy is just behind all of them, beyond all of them. And as you can see, we are seeing this single star from the far galaxy just because it is billions of times brighter than it was before exploding. This is a type 2 supernova, and it is just coming from the death of a massive star that, after burning several elements from the lighter to the heavier, it is now exploding, unable to burn its iron core. So basically complex physics is in action here. The nucleus of this massive star, a few times at least the mass of the sun, collapsed, and then at some point it just like a rebound. There was a wave, a shock wave, just destroying the stellar structure with such a huge explosion. As I said, the very complex physics is at work here, but basically it is the collapse of the iron nucleus. After that, the massive star we are seeing dying here just ended burning and creating other elements, because stars like the sun are just in their nucleus burning hydrogen to helium, and this can go ahead also at some point. Helium can just burn and produce carbon and oxygen. Then you have neon, you have oxygen, you have silicon and nickel and iron, but unfortunately iron cannot be made available to burn, and it is where the star has a few troubles, because a star is just in a very intriguing system, and it is in equilibrium because there are, of course, several things at work. Here it is a very simple explanation how star works. This is a picture from NASA. You see that the gravity acting on the material, just making the star, is trying to implode under the effect of its own gravity, but there is the pressure of the gas, but also the heat leaving the very hot core where nuclear fusion is in action. And while you have an equilibrium between the gravity imploding and the pressure and the heat leaving the core, just going outside, the star is in equilibrium. When the core stops just burning, producing heat, high energy, you lose a contribution to just survive under the weight of the star. And it is this very critical moment, the beginning of the catastrophic explosion of a supernova. This is why we call this kind of supernova the second type, that is a core collapse supernova. That is, I understand that the physics is very complex and I tried to do my best to preserve the mechanism, but it is a terrific explosion, and this is why you can see this very single star so bright despite the huge distance, my friend. While we are observing, there is a very huge moon out there, and of course this is why the galaxy is not showing at its best. Well, it's wonderful, but I have in mind how the galaxy was looking a few nights ago when we had no or just little moon. And I want to share with you an image I could capture soon after the supernova was discovered. Well, weather in Italy has been terrible, so I had to wait for 2 days before I had my own opportunity to have a look. Here it is, and it is nice because you can see in the larger image the supernova, and in the upper right inset you can see a picture, a fragment of the region of the galaxy of Messier 101 hosting the supernova taken about 11 years ago, 12 years ago, when of course there was no supernova, just to give you an idea of this cataclysmic explosion. And 4 days ago, blessed by a very clear and very stable, no wind weather, I could capture this masterpiece, my friends. How wonderful this galaxy is, called the Pinwheel Galaxy, Messier 101, located about 21 million light years from us. So, as I mentioned earlier, while we are observing via the Virtual Telescope project this object in real time, go back to the feed from the telescope, this explosion actually happened 21 million years ago. So keep this in mind. And this is the supernova, as I said. This is a core collapse supernova, as I said, a star with a huge mass, about at least 8 times the mass of the sun. And after just burning silicon into nickel and iron, this star faced a problem, that is the impossibility to burn iron into an heavier element. At this point, the core just started collapsing, okay, and all the structure started collapsing, and at some point there was like a rebound on a very dense core, involving, of course, some very critical physical condition like neutron degeneracy. And at some point this collapse reverted in a huge explosion, and that is the supernova we are observing. But we are blessed to have these things happening in the universe, truly violent event, and it is quite rare in our Milky Way. The last supernova in our Milky Way was observed in 1604, more than 400 years ago, by Kepler and Galileo. But as I said, we are blessed to have these catastrophic events happening in the universe, because they are supernovae to spread around new elements like carbon, for example. You know, carbon is such a pillar in our biology, and it was not the Big Bang taking care to create carbon. They were stars just burning hydrogen into helium, helium into carbon, and at some point exploding. That carbon was made available outside the stellar structure of the dying star to for other stars to born. And of course, from those carbon rich ashes, from a chemical point of view, here we are, my friends. So we are observing supernova. Here it is. Let me try to put in the center. So the star, you can see in the center basically is our supernova in Messier 101, discovered 8 days ago. The supernova is in the very center of the image. Despite a very bright moon, we are able to observe thanks to our robotic telescopes. Once again, the Virtual Telescope Project facility is making possible for many people to join and look at this amazing catastrophic event, even without having a telescope. And I must say, we are very proud every time. Weather is relatively good now, despite the moon, of course, and a bit of wind. I need to adjust now contrast here. I need to adjust also focus, I think, because the temperature is changing pretty fast. Let me do this in real time. I understand what happened because there was a filter used here. Sorry. Some technical stuff. As you know, the virtual telescope has been always sharing with friends everything. It is like if you were sitting in front of the telescope, okay? And we are doing this together. With the supernova, we are observing remotely. I'm amazed by this technology. No matter where you are on this beautiful planet, provided you have access to the internet, you can enjoy these things brought to you for free by the Virtual Telescope Project. By the way, I want to acknowledge our important technological partners, Software Bisque, C-Web and Telescope Live. And I also want to thank that handful of generous people who donate from time to time to keep our project alive. You are kindly invited to consider this possibility. You can support us because while we offer everything for free, as you can understand, there are bills to be paid and you can donate whatever you want. Just visit www.virtualtelescope.eu and look for the donate section. And from there, you can really support us. Of course, we need to adjust contrast and brightness after removing the filter. The supernova is always the source in the center. I will tell you what is happening. We are observing, of course, Supernova 2023 IXF. in Messier 101, and if you look, we are taking long exposures. What does it mean? You know, this is a faint galaxy. Well, while this is a bright supernova, keep in mind it is incredibly fainter than the faintest star you can see by naked eye, and well, more or less 100 times fainter than the faintest star you can see by naked eye under very perfect dark sky conditions. That said, it is faint, so you really need to capture light for some time, and this is where the telescope and the very sensitive camera we are using are making the difference. Look at the elongation of the star because it is windy, and I think I'm going to put the telescope in safe position. Just wait for this further exposure to end in 15 seconds. You see, we are collecting light for every image for 60 seconds. So for 60 seconds we leave our very sensitive camera exposed to the faint light coming from this supernova, and at the end we just display everything. Much better. Honestly, much better. 12 years ago, during our summer, it was August, if I remember well, another amazing supernova record setting at the time, 2011. FA just shoved in this galaxy in different position. Look here, and this one was a tape 1A supernova, which was much brighter than this, one magnitude at least, almost two basically, and we could also observe this old supernova. This is a different one, but over the months we could document the brightness evolution. I plan to do something similar with this supernova, the one we are observing now. So friends, at this very point I will ask our telescope to go to sleep, because I see that the wind is becoming an issue and we cannot risk to damage our very precious hardware robotic telescope. But I was very happy that I could show you this supernova in real time. Here it is, supernova AXF 2023 XF in Messier 101. I want to thank you for joining. I'm still sorry that we had to wait 24 hours more, but last night when the wind was terrible. So friends, thank you very much for joining. I hope that you had fun. I'm looking forward to host more and more events. Check the www.virtualtelescope.eu website to learn what is going on and what is coming on our website. I suggest you to stay tuned, just joining our Facebook page. Look on Facebook for the Virtual Telescope Project page, and also on Twitter. Of course, subscribe this YouTube channel, because we are really going to plan more and more. And on June 8th we will just explore the summer sky, sharing with you amazing images of some of the best cosmic gems out there. That's all friends, take care, keep looking up.